Namaskar and welcome friends to the AI School, the place where you learn anything and everything about artificial intelligence. We will be starting off with a course called Machine Learning Algorithms with Python. Here you will be learning about different kinds of machine learning, supervised machine learning, unsupervised machine learning, reinforcement learning, and their respective algorithms, their underlying mathematics and their applications through coding with Python. Along with that, you'll be learning about things like natural language processing and time series analysis. If you're interested in learning all of this, do join the course, do subscribe to the channel, and let's get started. So friends, a warm welcome to you in this course of Machine Learning Algorithms with Python. This course will give you a concept of what is machine learning, then proceed further into the different classifications of machine learnings, and then how those different kinds of machine learning classifications are executed through different algorithms. That also we are going to learn. So let's start with the first topic. What is machine learning? Let's say we have a machine which we want to use for some intelligent activity, right? We have a machine. Now on one hand, what we provide it is some data. We provided data. Now machine without any instructions does not really understand what to do with this data. So what we have to do? We have to provide it instructions. So we provided instructions. Now what are these instructions, friends? These instructions are basically maths and logic converted into code and fed into the machine. So this is maths plus logic converted into code and fed into the machine. So this is basically how the framework happens. Now the machine knows how to deal with this data. How to deal with this data means how to analyze this data to take decisions or make predictions. Now the machine can use this data to take decisions or make predictions. Now friends, let us define machine learning in a formal way. Let us try to do that. So friends, machine learning is the application of certain intelligent algorithms on data to achieve partial or complete automation of a certain task, such as making predictions or taking decisions. Now let's take some examples of machine learning. Let's say there is a machine which is part of a car and it enables the car to be auto-driving. Now how do we achieve that? Let's say this is the machine, auto-driving machine. Now in it we provide data in the form of images, mostly of tracks, roads, etc. Right? Lots of images we produce it. And apart from that, what we do is we give it instructions in the form of code. These instructions tell the machine which objects to avoid collision from and how to detect routes to travel in, right? So basically, the instructions enable the machine to analyze the images in order to navigate through the road. That is how this machine learning apparatus works, right? Now let's take another example. Let's say we have some database where there is a prediction of salary to be done. Let's say we have experience, we have seniority, we have college grades, and we have salary. So let's say there are 1,000 data examples like this. That's experience is like this, seniority is like this, grade is like this, that is YGPA is like this. And for this combination of experience, seniority and YGPA, this is the salary. Like this there are, let's say 8,000 examples. Right? We have 8,000 these kind of examples. And apart from that, there are 2,000 datas where experience is there, seniority is there, YGPA is there, but you have to predict this salary. Now what you can do, friends, is basically feed this data which is available to the machine. And using this data, the machine is going to create some equation which will enable it to predict the salaries when some experience, seniority and grade combination is given to it. And obviously the performance will be defined by how accurate the results are. So these are two examples where in one the machine is trying to make decisions, and in one the machine is trying to make predictions. So this is basically a overview of machine learning. Now one more important question that we have is, what is the relationship between AI and machine learning? Friends, AI is generally a technology that is intended to mimic human intelligence. AI is a technology that is intended to mimic human intelligence. ML is basically considered to be a subset of artificial intelligence or AI. Subset of AI. And its goal is mainly to use algorithms so as to make a machine execute certain tasks without explicit instructions. This is basically the relationship between AI and ML. Because of its functionality, machine learning is a very integral part of artificial intelligence, but artificial intelligence is the broader scope where all the plethora of human activities are generally being attempted to be replicated, right? AI is the broader universe where all kinds of human activities are attempted to be replicated, and machine learning is an important part of artificial intelligence because it enables machines to perform tasks in partial or full automated ways through the application of intelligent algorithms. What are the different types of machine learning? So machine learning, friends, can be majorly divided into three segments: supervised machine learning, unsupervised machine learning, and reinforcement learning. Let's try to understand what each of these mean. Supervised machine learning basically means the machine to take some decisions or make some predictions or do some task is using a data that is labeled. Now what do we mean by labeled data? Let's understand. Let's say we use the previous example only, that there is experience, there is seniority, there is grade, and there is salary. And we know that we are going to predict salary based on YGPA, seniority and experience. Now this knowing that we are going to find out what is the salary is basically what we call as a labeled data. We have a labeled data here, friends, because we know what is the outcome intended from this data, right? Another example let us take. Let's say there are various weather parameters like humidity, like cloud cover, like sun rays, availability of sun rays, etc., etc. Let us take these three parameters, and there is an option that it will rain or it will not rain. So rain or not rain. If it rains, we call it 1. If it does not rain, we call it 0. So based on these parameters, the machine has to make a prediction that whether rain is going to happen or not happen. This is another way of using some labeled data. Why labeled data? Because we know what is the outcome intended from this data, right? We have to predict whether rain will happen or not happen. Now, interestingly, these two examples comprise the major categories of supervised machine learning. This one basically is making predictions. Predictions in terms of the value, the absolute value of the salary, right? So, any experience, any seniority, any YGPA you give it, it can predict the salary whatever the number is. So this result can be a series of numbers or a continuous number system. This kind of labeled data and analysis of through supervised machine learning is known as regression. And in the second example, we were trying to understand whether rain is going to happen or not happen. So these are basically categories that we are trying to segregate the data into. This kind of supervised machine learning is called classification. This is called classification. Okay. Now here there were two categories, so we'll be calling it binary classification. But categories can be multiple. It can be 3, 4, 5, 10, whatever. So classification is not only limited to two categories. It can be multiple categories. So here we have tried to define supervised machine learning. Now let us try to understand what is unsupervised machine learning. Let's say there is a data given to a machine which constitutes the different minerals and their percentages of soil. Let's say magnesium, iron, carbon, phosphorus, lithium, lead, copper, all these kinds of minerals and their percentages, different percentages of content. This kind of data, and there are 10,000 such examples given, right? So there are 10,000 such examples given. Now, you do not know what to do with it. You do not have an outcome which is targeted, right? Now, in this case, what do you do? Herein comes the utility of unsupervised machine learning. Through certain algorithms which constitute unsupervised machine learning, this data can be segregated into categories or clusters. This data can be segregated into clusters based on similarities. Let's say there are 7 clusters found here based on similarities of data, right? So this kind of an algorithm or process of machine learning will be called unsupervised machine learning, and specifically one category of unsupervised machine learning which is called clustering. Now in unsupervised machine learning, there are categories like clustering, like dimensionality reduction. That is another category of unsupervised machine learning. Let us try to understand this second category now. Let's say there is a data with 10,000 features. Feature 1, feature 2, like this there are 10,000 features. Or say 5,000 features. Features means these kind of parameters. What are the different percentages of minerals? These are basically features, independent features. So here is also another data which has numerous features in it. Now, for a machine learning algorithm, this can become a curse because the machine finds the data to be immensely complicated, and whatever the decision it has to make, it becomes very difficult to arrive at. So there is a solution to it. What is the solution? The solution is eliminating those features which do not impact the data information too much and combining multiple features to get new features which can replace those multiple features and convert 5 or 6 or 10 or n number of features into one feature. So these two processes can be done to reduce the number of features. This process is called dimensionality reduction or dimension reduction. One of the famous ways of doing it is PCA, Principal Component Analysis. So main objective is reduce the number of features, but reduce it in such a way that information is majorly not lost. So as we understand, the major two categories of unsupervised learning are clustering and dimensionality reduction or dimension reduction. Now we'll get into the third category, friends. Reinforcement machine learning. What is that? Let's try to understand. Let's say a machine is being trained to play chess. Now, what is the situation here, friends? Basically, the machine has to take multiple series of decisions so as to arrive at a position where it is in a winning state. Now, this comprises of multiple series of decisions. There is a unique way by which a machine can be taught to become efficient at this kind of an activity. For every step the machine takes, there is either a penalty or a reward. A penalty or a reward. Right, friends? The machine's objective is to maximize the number of rewards and minimize the number of penalties. And every step is being awarded either with a penalty or a reward. Or this is basically a feedback system. The machine is getting feedback of each step through penalty and reward. And through that feedback, it is changing and reiterating its positions every time to make it better and better such that the maximum number of rewards happen and penalties are minimized. And over multiple reiterations, the machine ultimately becomes very, very efficient at playing chess or whatever task it is given to, which constitute this kind of a process. This method is known as reinforcement machine learning. Another example can be a machine or say a robot is given a task to walk across certain uneven ground positions. Now the robot is rewarded if its speed is high and also it can avoid falling. So each step the robot takes, it is given a feedback whether it is getting closer to falling or getting closer to slowing down, or it is getting faster and going away from the probability of falling down. This kind of feedback can enable it to become more and more efficient to walk through the uneven terrain at an optimal speed and without falling. So this is another example where reinforcement learning or reinforcement machine learning is being used. Friends, now we will look at the series of algorithms which are used in all these three categories. We will just know their names and have a brief introduction about them. And in the future classes, we'll be getting deeper into their underlying mathematics and their application in proper code environment. So friends, what are the different algorithms which we shall learn to apply in this course? First, we come to supervised machine learning, which constitutes majorly classification and regression. So as you can see, friends, there are a plethora of algorithms: linear regression, ridge regression, lasso regression, Poisson regression, ordinary least square regression or OLS regression, Bayesian linear regression. Like these, there are multiple algorithms, right? Least angle regression, ordinal regression, MARS, LOESS, logistic regression, knife Bayes, support vector machines, decision tree, random forest, gradient boost, ADA boost, XGBoost, CAT boost, K nearest neighbor. So among them, some of the algorithms are there which are used only for linear regression or only for regression, such as linear regression. Then there are some other algorithms which can be used for both classification and regression problems. An example can be decision tree. So we will learn their application in a code environment with Python very soon. For now, we will go into more number of algorithms of different categories. Unsupervised machine learning algorithms. So friends, first we come to clustering. Clustering is basically, we have an unlabeled set of data, and based on the similarities of features, these data sets are categorized into different groups or clusters, right? Now in this, there are multiple algorithms like k-means algorithm, k-means clustering, mean shift algorithm, dbScan algorithm, hierarchical clustering, minimum spanning trees, spectral clustering, Gaussian mixture model, quality threshold, etc., etc. Now, apart from clustering and dimension reduction, there is one more category which we can discuss about. This is called the association kind of algorithms. These kind of algorithms basically finds out associations between different datas. For example, two different clients have visited an e-commerce website. Now, depending on their behaviors, associations can be made between them. Or there are two different products in an e-commerce website. Now, depending on the behavior of clients on the purchase segment or the visiting segment, those completely two different products can become associated. This is one example where association is very much applied. And the algorithms used here are a priori algorithm, ECLAT, frequent pattern growth algorithms. Dimension reduction. Friends, we have already spoken about it. Let's say a data has a plethora of features, right? 1, 2, 3, 4, like 1,000 features or 5,000 features or 10,000 features. Here what we do is, let's say, fourth feature is not that important, not that impactful in preserving information of the data. So we eliminate it. Again, we see features 2 and 3. They can be combined to create a single feature. Single feature. We use this method to reduce further the number of features. So these are the basic processes through which, let's say, dimensionality reduction or dimension reduction can happen. The algorithms used are principal component analysis, locally linear embedding, singular value decomposition, subset selection, linear discrimination analysis, backward feature elimination, forward feature selection, non-negative matrix factorization, latent Dirichlet analysis, t-distributed stochastic neighbor embedding, etc., etc. Apart from all these algorithms, we now will move into reinforcement learning algorithms. So these algorithms can either be model-based or model-free. The model-free algorithms are Q-learning and SARSA, state action, reward, state action. These two are model-free reinforcement learning algorithms. Then the model-based ones are Markov's decision process, Bell equation, and Monte Carlo research. So these we will try to learn. Apart from this, I have written two other kinds of machine learning processes, which are natural language processing and time series analysis. These two we'll also definitely learn in this course. The one thing which we will leave for a separate course, completely separate kind of course, will be deep learning and neural networks. We'll be covering it in an upcoming course which will subsequently follow this course. So friends, let's get on with it. So that's about it, friends. Our next stop is linear regression. Our first algorithm, which belongs to the category of supervised machine learning. We'll learn how to do coding for linear regression. Let's proceed to that, friends.